In 2.2, we're going to be dividing polynomials. And think back to when you did division, like long division. If I had 648 divided by, let's say, 4. So we put 4 on the outside and 648. There's this process we go through to find the answer. And a process you follow to get to a result is called an algorithm. So an algorithm is this system that you work to get the answer. So for long division, the algorithm says, how many times does 4 go into 6? Once. So I put a 1 on top, and then I do 1 times 4 is 4, and then I subtract. And I get 2. What's next? Bring down the 4. And then 4 goes into 24 6 times. 4 times 6 is 24. Get a 0. Bring down the 8. And then 4 goes into 24. 4 goes into 8 twice. 2 times 4 is 8. And I get 0. What does this 0 represent? It's the remainder. There was nothing left over. So if I had a rope that was 648 feet long, and I asked you to cut it into 4 equal pieces, each piece would be exactly 162 feet. Okay? Let's do another one. Let's do, how many times does 3 go into 774? Nope, 5. Okay. 3 goes into 7 twice. 2 times 3 is 6. I subtract, I get 1. Bring down the 7. 3 goes into 17 5 times. 5 times 3 is 15. 3 goes into 25 8 times, and 3 times 8 is 24. And I subtract, and I get 1. What do I do with that 1? Ah, good. Do you remember when you did this in elementary? Well, think about this. I have a rope that is 775 feet long, and I ask you to cut it into 3 equal pieces. So you do the math, and you cut it into 3 pieces, and you bring me 3 ropes that are 258 feet long, and then you bring me a 4th rope that is a foot long. Have you completed the task? No. Right? We can't cut that rope up and glue it to the other ropes. It just doesn't work that way. So one way to deal with remainders is to write remainder 1, but that really doesn't make sense. So Ryland, who's on his phone when he shouldn't be, I know, it's okay. First 2 are free. So what did you say? What should we do with that 1? So we're going to put 1 over 3 because of this 3 right here. So the true answer is 258 1/3 feet. And really, there's a plus sign right here, but we don't bother to add the plus sign. Okay? So there are 2 ways to deal with remainders. One is just put the remainder. The other is to write plus the remainder divided by the original divisor of 3. I don't know. Don't know. Okay. So we are going to divide polynomials. And the polynomial division has an algorithm that is sort of like long division. I mean, it's a series of multiplications and additions that we put together, and it's going to look really weird. It's not difficult to do. It's very easy, but you have to make sure that you get all the steps correctly. Okay? All right. So, yeah. So let's say I had x to the 4th plus 2x to the 3rd minus 6x squared minus 8x minus 1. Wait a minute. Let's Go do that. Okay. And then we're going to divide that by x minus 1. Okay. Well, if I have 72 divided by 12, really 72 is 2 times 2 times 2 times 3 times 3. And 12, let's just say 3. So 3 is one of the factors of 72. Does that make sense? So the answer would just be all of this multiplied together. 2 times 2 times 2, which is 8, times 3 is 24. So 72 has a bunch of factors. I just made it up. Okay? But that's how division works. If any of the factors are the same, then they cancel. So if I had 72 divided by 15, then it would look like this. Can I cancel anything? The 3's work, but the 5 doesn't. So the answer would still be a fraction. Okay? If I divided it by 12, that would be 2 times 2 times 3. And I would cancel that, and the answer would be 6. Okay? So polynomial division works the same way. This is an x to the 4th, which means it has 4 factors. And we're dividing by x minus 1. If x minus 1 is one of the factors in the numerator, then those will cancel and I will get remainder 0. Does that make sense? So this equation on top is built by 4 linear factors. If x minus 1 is one of those, then the division will go in evenly and I will end up with no remainder. What if it doesn't? Then the remainder here will be something other than 0. That's how we tell. If the remainder is 0, that means that it worked. It went in evenly. If the remainder is not 0, that means it didn't go in evenly. Okay, so pull out a piece of paper because you'll want to write this down. Forever. Yep. Never. It had better be. And people watching this video are wondering who I'm talking to and what we're talking about. Caden. Caden the Barbarian. All right. Here's how you complete the division. We're going to use an algorithm that's called synthetic division. So the other algorithm I showed you was long division. Synthetic division will allow us to divide some polynomials. So your first step is write equals 0 in the denominator. Okay? What makes the bottom 0? Well, solve. Add 1. Yeah. So I get x equals 1. Yep, add 1 to both sides, and I get x equals 1. Well, whatever's in the bottom. Yeah. Okay. Now take that number, and you put it kind of off to the side in this little corner. Okay. And then we're going to write all of the coefficients. So the numbers in front of the x's, we're going to write all those down. So 1, 2, 6, -8, and -1. Okay. And then I draw a line, leave a little bit of space. And we follow the same process all the way to the end. So we're going to drop down the 1. And then we take 1 times 1, which is 1. And then I add. 2 plus 1 is 3. Then I do the same thing. 1 times 3 is 3. And then I add. 6 plus 3 is 9. And then 1 times 9 is 9. And then I add. Negative 8 plus 9 is 1. And then 1 times 1 is 1. And negative 1 plus 1 is 0. And that 0 is our remainder. Well, no, that's not. That's how we find the answer. So let me review the steps. You take the denominator and you set it equal to 0 and you solve for x. Whatever number you get there, you stick it in the corner, and then you write all of the coefficients of the equation. 1, 2, 6, negative 8, negative 1. No, it's got to be 0. It's got to be 0 every time. Okay? So, I'll show you that in a second. In order for this to work, these need to be in order. 4, 3, 2, 1. You see that? It's got to be written out in order or this isn't going to work. So, if I had x to the 4th and I divided it by x, what would that give me? X to the 3rd. So if you look carefully, I have an x to the 4th, and I divided it by an x, which is going to give me x to the 3rd. So this number right here was an x to the 4th, which means this number right here is now an x to the 3rd. Okay, see that? So my result, these right here, are my new equation. So my original equation was an x to the 4th, which means that my answer equation is an x to the 3rd. Yeah, you're taking an x away from each exponent. So this got divided by x, which gave me x to the 3rd. This got divided by x, which gave me x to the 2nd. This got divided by x, which gives me x. And then that got divided by x, and then the number ended up turning into my remainder. Okay, so let's do another one. We'll do kind of a short one. Yeah. Well, this is the easy way to do it. We divide polynomials all the time. And you probably won't make it far enough into math. Most people don't make it far enough for this to make sense. But what we do is we take real world situations that are incredibly complicated and we turn them into this type of equation. And that type of equation is really easy to work with. So like your cell phone works in polynomial format because it's just so much simpler than the actual method would be. Oh, I'm teaching you how to learn and how to think. It's not that you're going to use this. Okay. Hey, you signed up for this class. All right. So at the denominator, we write equals 0. Okay? I solve for x, and I get x equals 2. That's the number that goes in the corner. And then what do I write next to that? 1, -7, 10. Everybody follow so far? So I drop the 1, and then I multiply, add, multiply, add. 2 times 1 is 2. -7 plus 2 is -5. 2 times -5 is -10. And 10 minus 10 is 0. Okay? So, what is my answer? 1x minus 5 with no remainder. I will. But before I get there, I want to show you a couple things. So, what just happened? Well, let's look back at the original. Does the top factor, can you think of two numbers that multiply to be 10 and add to be -7? -5 and -2. Does anything cancel? So this cancels that, and what am I left with? That right there. Does that make sense? So for the bigger equations, if I had an x to the 5th divided by an x plus 1, what I'm asking is that top has 5 factors. Is x plus 1 one of those factors? Well, it depends. If the remainder is 0, then yes. If the remainder is not 0, then no. Right? Okay, so Q wants to do one without or with a remainder. So write this down. No, I'm going to work it with you. Well, this one's not going to work. Well, the first two I used a couple tricks to make them work. Right. Okay, so first step equals 0. Subtract 4, x equals -4. And chances are this one's going to be really nasty. These are harder to make work than you realize. So I put -4, and then I write down all the coefficients. 3, -6, -2, -8, and 5. Draw the line, drop the first one, and I get 3. Ooh, this is going to be bad. Whatever, we'll just go for it. -4 times 3 is -12. 6 minus 12, -6 minus 12 is -18. Ooh, ugly. Okay, that's too bad. Let's change that to a 1. It won't be quite as bad if we do that. All right, drop the 1, and let's make this a +6. So, Caden, you asked how I can do it. Apparently I can't. So, -4 times 1 is -4. 6 minus 4 is 2. -4 times 2 is -8. -4 minus 8 is -10. -4 times -10 is 40, which gives me 32. 4 times 32 is 120 plus 8, 128. Minus 128. which gives me negative 123. I have. Okay, is anybody confused at what I did? I'm sorry. So the pattern is multiply and then add, and then multiply and then add, and then multiply and then add. So what is the answer? Well, my answers are right here, and the original was x to the fourth, so the new one is going to be x to the third. So x to the third plus 2x squared minus 10x plus 32. And then one way to do it is remainder negative 123. Okay? Or, if we do Ryland's method, it's plus negative 123 divided by the original x plus 4. Yeah, but there's still a little bit you need to know. So, which answer do you use? Well, technically they're both correct. Mathematically, this one is much more useful, but your assignment in ALEKS will tell you which one it wants you to do. Right, so either that or this. Yeah, you use the original. Okay, so that's almost everything. There are two other little tricks. Okay, the first one is this. Okay, what number do we put in the corner? Negative 3. Okay, well, let's put that down a little bit. What are my coefficients? 1, 2. No. 0. This one's a little bit different. Oh, yeah. So equals 0 minus 3, x equals negative 3. I already put it over here. I just didn't write it down. So, what do you notice about the numerator? There's no x squared. Okay? If I don't put a number there, then my answer will be smaller. It will have fewer numbers. Right? So look at the exponents. 4, 3, 1. I'm missing an x squared. There is no x squared. But I have to put it in the equation. So look at the x's. X to the fourth, x to the third. There is no x squared. It's missing. So it's kind of like, let's see if I can do this. I'm going to take this stuff and I'm going to move it over. And I'm going to write plus 0x squared. So I need to put a placeholder 0, negative 16, and 7. So you always have to check and see, was anything missing? Because if something's missing, you need to put a 0 in its place. And then it works just like you would expect. Drop the 1. Negative 3 times 1 is negative 3. Yes? Yeah, anything that's missing, you need to put it in. So if I had like x to the 6th plus 2x, then you would have to do 1, 0 for the 5, 0 for the 4, 0 for the 2, or 3, 0 for the 2, and then 2, and then 0 for the constant. No, you don't have to go up. You have to go down. Yeah. You just put a 0 in its place. Yeah. Okay, so we drop the 1. Negative 3 times 1 is negative 3. 2 minus 3 is negative 1. Negative 3 times negative 1 is negative 3. Or positive 3. Bring down the 3. Negative 3 times 3. Oh, that's supposed to be a plus 16. I'm sorry. So negative 3 times negative 3 is negative 9. 16 minus 9 is 7. Negative 3 times 7 is negative 21. And that gives me a remainder of negative 14. Okay? Now, if I forget this, then I won't have 4 numbers down here. I'll only have 3, and half of them will actually be the wrong number. Okay? So my answer is, well, it started with an x to the 4th, so now it's x to the 3rd minus x squared plus 3x plus 7, and then depending on the type of problem, it's either remainder negative 14 or it's plus negative 14 over x plus 3. Okay, do you want to see another one like that? No? Okay, there's one more little thing that happens that messes things up. Okay. So let's do ooh. Hold on. That's gonna make our lives difficult. Okay. Yeah. So we write equals 0. How do we solve for x? What do? Subtract 1, and I get 2x equals negative 1. Divide by 2, and I get x equals negative 1/2. So that's the number that we put in the corner. Ah, good eye. We need to write the coefficients. What are they? 2, 0. Does everybody understand why it's a 0? I don't have a third. I have a 4 and a 2. This is a 1. No, the 3 goes right here. So we pretend that it's 0x to the 3rd. So 2, 0, 4, 6, 18. We good? Okay. Drop the 2. What is negative 1/2 times 2? Negative 1. 0 minus 1 is negative 1. Oh, shoot. Oh, so this is going to be ugly, but negative 0.5, actually positive 0.5. So we get 4.5, and then negative 2.25, so that would be 3. 3.75, and then 1 point. Anyway, they won't end up doing that on your assignment. There will be no decimals. Okay, but do you get how I got the -1/2? Now, oh shoot. Well, that I totally broke it. I was going to teach you something, but we have to do this. Okay, let's try number 2 right here. So I put -1/2 in the corner. Am I missing any numbers? No. So 4, 14, 18, and 14. Okay. There was one thing that I needed to show you, but that equation broke, so I couldn't show you. So I dropped this. -1/2 times 4 is -2, which gives me 12. -1/2 times 12 is -6, which gives me 12. -1/2 times 12 is -6, and I get 8. Now, here's the trick. Now I got the hiccups. If there's a number right here, then these answers are too big. Not the remainder, but I need to divide each one of these by 2. So 2x squared, excuse me, 2x squared plus 6x plus 6, remainder 8. Right. The other version would be 8 plus 8 over 2x plus 1. Okay. So I think we should do one more, but first, so for question number 2, all you have to do is write the answer and then write the remainder. But for question number 3, you need to fill out the whole synthetic division. See how it's got everything written out for you? So you drop the -1. -7 times -1 is 7, which is 0. -7 times 0 is 0. 0 plus 0 is 0. -7 times 0 is 0. Remainder 9. So the final answer there, which you put right here, would be -x squared. And then it's plus 0x plus 0, which you don't need to write. And then plus 9 over x plus 7. Okay? All right, so let's do, let's look at a couple of these. Uh-oh, I broke it. Okay, let's do number 8. So what number goes in the box, in the corner? Does everybody agree? Equals 0, subtract 2, divide by 3, -2/3. So -2/3. And then, am I missing any coefficients? Nope. 12, 11, 17, 18. All right, drop the 12. What is 2/3 of 12? So 12 times 2 is 24, and 24 divided by 3 is 8, so it'd be -8. 11 minus 8 is 3. What is -2/3 of 3? Well, you multiply the tops together and then divide by the bottom. So negative 2 times 3 is negative 6. Negative 6 divided by 3 is negative 2. Negative 2/3 times 15. 2 times 15 is 30. 30 divided by 3 is 10. Minus 10. And then I end up with 8. Now, because this number is a 3, I have to divide all of these by 3, or I'll get the wrong equation. Notice I didn't touch the remainder. I only touched the coefficients. So the original problem was an x to the third, and then I divide each one of those by 3. 12 divided by 3 is 4, x squared. 3 divided by 3 is 1x. 15 divided by 3 is 5. And then plus 8 over 3x plus 2. All right. Look at number 9. Are we missing anything? A 1. So notice 1, 6, 0, negative 9. Okay. That's everything you need. Get to work. I'll look.